Hey guys, this is Mrs. Keith. I'm sorry that I'm out today. I thought I would just kind of go over these notes. Maybe that'll help a little bit since I'm gone. We're going one step further in today's notes. The extra step that we're going to be doing is we're going to substitute and solve for C. Whatever your initial condition is, you're going to be substituting that in. So we're going to get our y's on one side, our x's on the other side. So to do that, you'll have dy over y equals 3/4 dx. Now, if there's a constant here, I usually leave it on the right-hand side and move the dx with it. I don't move it over with the y. Okay, so now we're just going to go ahead and integrate both sides. And when you do that on the left-hand side, you get natural log of y equals 3/4 x plus c. All right, now we're going to plug this in. This is the ordered pair 0, 10. You can either plug it in at this stage right now, or you can wait and plug it in after we solve for y. I'm going to go ahead and solve for y. When you do that, you're going to get different c values depending on when you plug it in. So, but you should get the same final answer. So here we're trying to get y out of the log. So we'll we'll raise e to the on both sides. So on the left-hand side, we'll end up with y equals, this is e to the 3/4 x plus c. And then remember, we can rewrite this as e to the 3/4 x times e to the c, which that's just a giant c right there. So we end up rewriting it as y equals big C e to the 3/4 x. Now at this point, I'm going to go ahead and plug in that ordered pair. So we're going to say 10 equals C e to the 3/4 times 0, which that's just e to the 0, which is 1. So C equals 10. Now you can just plug that in to your equation. So y equals 10 e to the 3/4 x, and that's your particular solution. All right, on the next one, again, get your y's on one side and your x's on another. So we'll have y dy equals x squared dx. If I integrate both sides, I get y squared over 2 equals x cubed over 3 plus c. If I go ahead and solve for y, I'm going to multiply everything by 2. Because remember, we undo our order of operations backwards. We undo any adding and subtracting on y, which there isn't any, and then any multiplication or division on y, and then undo the exponent. So this becomes y squared equals 2x cubed over 3. And then, technically you're doing 2 times c, but it doesn't matter. C just represents a constant, so we don't have to show that. We can just leave it at c. All right, and now remember, when you're unsquaring something, you take the square root, and you're supposed to do a plus or minus right here. We talked about that last class. The difference with what we're doing today and what we did last class is you've been given this initial condition. If that -2 right there, if that y value is negative, then we're going to choose the negative on here, not the positive. If it had been positive, we would have chosen the positive, but you won't do both. You'll do one or the other. So now I've got that solved for y. I'm going to go ahead and plug in our ordered pair, 3, -2, to solve for c. So -2 equals a negative square root of 2 times 3 cubed over 3 plus c. That gives me, I'm going to multiply both sides by -1. So I have 2 equals, underneath there, 3 cubed is 27, divided by 3 is 9, and 9 times 2 is 18, plus c. And then you're trying to get c out of the square root, so we'll square both sides. That undoes the square root. So you're left with 4 equals 18 plus c. So c equals a -14. And now you can go back, and you always go back and you plug it into the equation that you plug the ordered pair into. At that point, that's the one you're going to be plugging it into. So your final answer will be y equals a negative square root of 2x cubed over 3 minus 14. And that's your particular solution. All right, on the next one, I'm going to get my y's on one side and my x's on another side. So we've got e to the 2y dy equals 3x squared dx. I'm going to integrate both sides. And so remember on the left-hand side, think of u being 2y. So du will be 2 dy. So when you do substitution, you'll write this as e to the u, but I needed in there to replace the du, I needed a 2 dy. So that means I need a 1/2 on the outside. So we'll have a 1/2 here. And that allows me, I didn't do that very well. Let me back up, make that better. Sorry. Sorry, y'all. Okay. So here we had e to the 2y dy. Again, I'm going to let u equal 2y, so du equals 2 dy. All right, and I was integrating both sides, I forgot. So I'm going to go ahead and make this one the way I need it to look to be able to substitute. So e to the 2y, I needed this to be 2 dy. In order for me to add that 2 in there, I have to put a 1/2 out front. And that equals over here, this one's easy to go ahead and integrate. This will just be x cubed plus c. And then over here, you can go ahead and substitute. This is e to the u du. When you integrate e to the u, it's just going to be e to the u. So you've got 1/2 e to the u, which u happens to be 2y, equals this. Oops, I don't know why I put it right. Sorry. All right, now I'm going to go ahead. I'm not going to solve for y yet. I'm going to go ahead and plug in the sorted pair. The sorted pair is the ordered pair 0, 0.5. And just to show you a different place to plug in. So this is 1/2 e raised to the 2 times 0.5 equals 0 cubed plus c. So c will equal, over here, e will be raised now to the first power. So this will be e over 2. And then when you plug it back in to where you plugged in the point, we plugged in the point at this stage right here. I've got to go back to that stage to plug in the c. Wherever you decided to start plugging in, you've got to go back to that to plug in c. So doing that, I'm going to get 1/2 e to the 2y equals x cubed. Now it's plus e over 2. I'm going to multiply both sides, or yeah, both sides by 2, or every term by 2, really. And so I end up with e to the 2y equals 2x cubed plus e. And then we're going to get y out of the exponent field, so you have to convert it to a log. And I believe the way y'all learned it last year is you just take the natural log of both sides. When you do that on the left-hand side, that simplifies to just be 2y equals, over here, this stays natural log of 2x cubed plus e, and then divide by 2. So you've got y equals the natural log of 2x cubed plus e. You can say over 2, or you can put a 1/2 out front, which, if you remember your log rules, that 1/2 becomes the exponent of that argument. So you could also see it as y equals natural log of the square root of 2x cubed plus e. But either one of those is your particular solution. On the next one, I'm going to go ahead and solve for, get y's on one side, dy's, ty's and y's together, dx's and x's together. So I'm going to get y dy equals, over here, I'm going to have 1 plus x over x dx. I'm going to integrate both sides. On the left-hand side, that just becomes y squared over 2. On the right-hand side, you can't let u be anything here because the du isn't there, but hopefully you see I can do 1 divided by x and x divided by x and break that up into 2 separate terms. So you can write this as 1 over x plus 1 dx. And so when we integrate that, the integral of 1 over x is just natural log of x, plus the integral of 1 is x, and then plus c. And I'm going to go ahead and plug in my point, which is 1, -4. So when I do -4 and I square it, divided by 2, equals natural log of 1 plus 1 plus c. On the left-hand side, that'll become 8, equals natural log of 1 is just 0. So you end up with c equals 7. And now you're going to plug it back into where you plugged in your point, which was right there. So this will become y squared over 2 equals ln x plus 7. And then you're going to multiply both sides by 2 to solve for y, making sure you distribute that 2 to every term. So that becomes y squared, equals 2 ln x plus 2x plus 14. And then we take the square root to solve. So you have to go back to your original initial condition. That initial condition has a y value that's negative. So we'll do the negative square root of this. So it'll be 2 ln absolute value of x plus 2x plus 14. And that's your particular solution. All right, on number 5, getting x's and y's together. So this will be dy over y squared equals x cubed dx. I'm going to integrate both sides. So remember, this y on the bottom, it's not to the first power. It's right to the second power on the bottom. So this one, we're just doing the power rule. It won't be the natural log. So I'm going to rewrite this as y to the negative 2 dy equals, over here, this will be x to the 4th over 4 plus c. So then over here, when we integrate this, it'll be y to the negative 1 over negative 1 equals that x to the 4th over 4 plus c. Rewriting this is negative 1 over y equals x to the 4th over 4 plus c. I'm going to go ahead and plug in our point now. So if I plug in 2, 1, I will get a negative 1 over 1 equals 2 to the 4th over 4 plus c. That's negative 1 equals 4, because 16 divided by 4 is 4, plus c. C will be negative 5. So then going back to the equation where you plugged in that point, that's where we're going to plug in c back into that equation. So it'll be negative 1 over y equals x to the 4th over 4 minus 5. All right, now we need to solve for y. Y is in the denominator here. So I need this to become one fraction. As long as I have one fraction equal to one fraction, I can cross multiply. So let me move this up here and rewrite it real quick. I'm going to rewrite 5 as 20/4. So we have a common denominator. Excuse me. Okay, so we have one fraction equal to one fraction. Now I can cross multiply. And so that will become a negative 4 equals y times x to the 4th minus 20. We're solving for y. So y will equal a negative 4 over x to the 4th minus 20. And that's your particular solution. All right, on number 6. Again, I like to keep the constant on the right-hand side with the dx. So I'm just going to move the 4 minus y over. So this will be dy over 4 minus y equals 3 dx. And then I'm going to integrate both sides. Okay, when I do that, think of this over here on the left, u equals 4 minus y. And so du equals negative 1 dy. It's a chain rule situation, so we got to think of it in those terms. So I need a negative 1 up here, which means I need a negative out front. So this will become a negative natural log of 4 minus y. That 4 minus y is raised to the first power, so on the bottom, so it's going to be a natural log. And then this will be 3x plus c. I'm going to go ahead and plug in my point here because I'll end up with natural log of 1, which will become 0, which is nice. I'm going to plug that 3 in there. So that'll be a negative natural log of 4 minus 3 equals 3 times 2 plus c. That's negative natural log of 1. Natural log of 1 is just 0. So we end up with 0 equals 6 plus c. So c equals a negative 6. Excuse me. I'm sorry, y'all. Okay, so now plugging it back into where I plugged it in, the point in, which was right here. We get a negative natural log of 4 minus y equals 3x minus 6. And then again, I'm solving for y. We have to undo our order of operations backwards. So I have to undo that multiplication right there first. So I'm going to multiply both sides by a negative. So this becomes natural log of 4 minus y equals a negative 3x plus 6. And then we're going to get that argument out of the natural log. So do the e thing on both sides. So this will end up being 4 minus y equals e to the negative 3x plus 6. Move your 4 over. That'll be minus 4. And then divide through by a negative 1. So we get y equals a negative e to the negative 3x plus 6 plus 4. And that's your particular solution. All right. On the next one, we have a little bit more to do this time. We've got our order pair here, 3, 2, that we're going to be plugging in. But we also, after we do that, we want to know what y equals when x equals 2. So it's just one more step. Okay, so here we'll have dy over y equals x squared dx. When I integrate both sides, I get natural log of y equals x cubed over 3 plus c. Plug in my ordered pair if you want to here, or solve for y. Either way is fine. I'm going to go ahead and solve for y. And so this will be y equals e to the x cubed over 3 plus c, which remember is e to the x cubed over 3 times e to the c, which is just a giant c. So c equals e to the x cubed over 3. Now I'm going to plug in my point. So 2 equals c, e to the 3 cubed over 3. That's 2 equals c. That's 27 divided by 3. So we get 9. And so c will equal 2 divided by e to the 9th. Plugging that back in, I get y equals 2 over e to the 9th times e to the x cubed divided by 3. Which remember, that's the same thing as saying y equals 2 times e to the negative 9 times e to the x cubed over 3. So you could also write it as 2 e to the x cubed over 3 minus 9 if you wanted to. So now we're going to plug in when x equals 2, we want to know what does y equal. So y equals 2 e to the 2 cubed over 3 minus 9. So we get 2e to the 8 thirds minus 27 thirds. So y equals 2e to the negative 19 thirds. And you could rewrite it as y equals 2 over e to the positive 19 thirds. And that's your answer. All right. And then y'all got some in-class practice you can work and some actual practice. So please let me know if you have any questions. Thanks, y'all.